Ah, what's I'm doing? Complete doofus. Later. Okay, so can folks at home hear me okay? Something? Yep, good, thank you. Okay. Okay. Okay, so it's 9:15. Let us commence. Um, so battle plan for today is to first talk about the exam. The first midterm is in theory this week. So we need to talk about what that's going to look like, what the timetable will be, what kinds of things will be covered on it, especially since the whole schedule has shifted in weird ways. But I think I want to stick to our original date and do it this week. And there'll just be a little less on it, and that'll be fine. Uh, uh, so I want to talk about that. Then I want to see if there are any questions about stuff that we've done so far. Problems people have had, say with the collage assignment, or confusion that's come up as a consequence of working on that, or other things. And then as time allows, we'll actually talk about mirroring. We haven't actually talked about mirroring. We've read stuff about it in the book, but I know there have been a couple of questions about it, and I want to spend some time talking about mirroring and how that sort of plays out, okay? So are there any big picture questions before we launch in and start talking about the exam setup? Going. Any questions at home? Okay, so let me share screen, whiteboard. I'm gonna scoot over here to my nifty little drawing pad. Better. Now it's visible again. So let's actually draw this week. So let's see. That's probably a little more than I wanted. Whatever. Okay. So then this will be Monday. That's today. So today, Tuesday, Wednesday, Thursday, Friday. And then we got Saturday and Sunday, whose role will become clearer in a second. And then we have Monday of the following week. So here's my plan, and I am totally open to having everybody go, no, terrible, don't do this, right? But we got to have a plan, see where we go. So the current schedule has the exam on Friday. So my idea is to have an in-class portion on Friday that will be online and as a Canvas quiz. Man, I cannot spell. I got excited when I realized I misspelled Canvas, and then I misspelled quiz too. So my idea is that we'll have an online quiz Friday during the scheduled class period that will be multiple choice, matching, and short answer. It will be small stuff that you can sort of work through fairly quickly, hopefully, okay? And I will be available online at the same time to answer questions as they come up. So we would do that. Like, I probably won't be here in this room. I'll probably be at home, and we'll have a Zoom room with a waiting room, and you can come in and ask questions as we go. And then there'll be a take-home part. So my idea is to release the take-home part tomorrow night. And take-home is due Monday, at 10 p.m. So the take-home will actually have some like programming stuff in it. The in-class will be more conceptual, like, do you understand what's going on, kind of stuff. The take-home, you'll actually have to write a little Python code, okay? And if you understood and are feeling pretty good about the collage assignment, I would expect the take-home to be pretty straightforward. If there are things about the collage assignment that you're concerned about or confused about, I would totally ask questions, because they may indeed be relevant to the take-home part of the exam. But part of the idea of releasing the exam Tuesday and having it due the following Monday is it gives you time to procrastinate, although that's not actually the intent. It gives you time to start, get stuck, ask me questions, get unstuck, and keep going. You are absolutely allowed. You are allowed, encouraged, enthusiastically encouraged to ask me questions during the take-home part of the exam. don't feel like it's your job to just suffer mightily for 5 days, being miserable and sad. That is not what we're trying to do here. So the goal is for you to be able to, succeed on this. I want people to do well. And so absolutely ask questions on the take home part of the exam. If you, give it a start and you're even Tuesday night, you take a stab at it and you come in Wednesday morning, you're like, I don't understand what you mean by this, blah, 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 right? If you have general questions like, what does this mean? That kind of thing, definitely ask those in class or sort of in public venues, and that's totally fine because it probably helps other people. If you have questions about your specific work, like I thought this would do it, but it doesn't seem to do the right thing, that should be a one-on-one thing, obviously, because we don't want you like plopping your code up on the screen for everybody to look at. That would not be as good, okay? But absolutely, absolutely, absolutely ask questions, okay? So that is my proposal for the schedule for the exam. Are there questions about that? Are there concerns about that? Does that seem okay? Does that seem terrible? Tell me a story. Anybody, online or in the room? Yeah.
So for the Friday portion, we'd be taking it during the class period, but not in this room, just in our.
You would be in, yeah, I'm just going to trust you. So the question, if you couldn't hear at home, is for the Friday in class part, where are we going to be? And because some people simply cannot physically be in this room, I want it to be as uniform as possible. I don't want to have some people have to come to this room and some people get to be in their, homes. I can't fix everything. I mean, for some people, it will be 10:15 p.m. when the exam starts, and there's nothing I can do about that. But my goal is to try to make it as uniform as possible so everybody will be able to take it in your space. I am going to trust you because I don't really have a lot of options and you're adults and I don't have a reason not to trust you, actually. I think you're all cool people. So, I'm going to trust you to do the right thing. And because it will be set up the way that it will be open book. The in-class part, I mean, the take-home part's like, yeah, I mean, it's really open kind of everything because I can't do much about that. The in-class part is definitely open book. I would discourage you from Googling around. If for no other reason, I don't think that's a good strategy. You'll need to try to get through everything in an hour. And I don't think strategically trying to Google for a bunch of stuff is going to be a good way to approach that. But definitely open book and open note Friday. So feel free to prepare accordingly. And we can talk some about what might be on the exam, like, because that is frequently a useful thing. And so I was thinking we'd spend maybe Wednesday. We can do some of that today, but we would spend a lot of Wednesday talking about, what might be on the exam Friday and going over questions about the take-home part of the exam, since that'll be released on Tuesday. So, comments, questions, suggestions, concerns? Anybody? Going? Anything in the room? Anything online? Okay, that's the plan. So I will get the take-home part rolled out tomorrow night. I'll also try to get a kind of list of topics for the in-class part rolled out tomorrow night as well to help to prepare the conversation on Wednesday. Okay. So any questions? Okay. Then, are there any general questions? Questions about making collages, about manipulating images, about for loops, about strings, stuff like that before we start talking about mirroring? Anything? Anything at home? Not seeing anything. Okay, not seeing anything here. Let's do some mirroring action. I will go back to the whiteboard for a second. And I'm going to make you like that. And I'm going to click you. Okay, so there are a number of examples in the book about making mirror images of things. But there were a number of questions that came up about that. So I want to talk about that and have us do an example. So let's imagine we have a picture and it's got like a tree. It's a funny looking tree, but I don't do drawing well. And a person, okay? And we want to make a mirror image of that. So we want to make a new picture that is like the old picture, but it's twice as tall, and the top half has been mirrored down into the bottom half. So it looks kind of like this. Does this make sense? Do we understand the question I'm trying to solve? And you can get some very cool effects with things like this. If you have seen the TV series Dark recently, their opening credits use mirroring in some crazy and sort of mind-bending way, which is fitting for a show that is crazy and mind-bending in its own way. So how do we do this? Okay, so let's just stick to this version of the problem for starters. So if the width of the original picture is W and the height of the original picture is H, so that's just the original picture. What's the width and height of our new picture going to need to be? So what's the width and height of the canvas we need to work with? In terms of W and H. How big does the new canvas need to be? Joseph.
So the width should be the same.
Yep, the width should be the same, right? We haven't done anything to change the width by mirroring it. Correct. Since the images are the same, 2 times H will give us the height of the new picture. The new picture will be the old height twice because we're stacking them on top of each other. And we're not doing any overlapping or anything that would alter the height of the resulting image. If you wanted to overlap or leave a space, right, that would change things. But if we just want them to join up, which is what I'm shooting for here, 2H is going to be the desired height. So we know that's going to be the size of the canvas we need to create. And we will need to create a canvas because the image we're after is bigger than the image we started with. So we can't just like modify the original image in place. We need to make a new image, okay? So then the question is like, well, what are we going to do here? That means we're going to have to copy the image twice into the new space. Okay. So the first copying is pretty straightforward, and we've done examples of that. You've done that on the collage assignment. This is pretty much no problem. The second copy, however, is the kind of weird one. And in the copying that we've done before, we've usually done things like, let's do this in yellow, we've tried to move like this pixel to this location. But that's not what we're going to want to do here. Because that would just give us oh, sorry. Let me back up. I messed that picture up. Because really, I should be copying from this up here. We've been taking like this pixel and we've been copying it down to here. But that's not what we want. Bad. Because that's just going to give us the tree and the person still upright. If we copy top left to top left, top right to top right, bottom left to bottom left, bottom right to bottom right, we'll end up with the same picture orientation. And we're trying to mirror the picture, right? That's not going to work. So what we want is we want this pixel, do this in green. We really want this pixel to go down here, right? If it was on the top of the original image, we want it to be on the bottom of the mirror. And if it's on the bottom of the mirror, we want it to be on the top of the mirror. If it's on the bottom of the original, we want it to be on the top of the mirror, right? So we want to swap tops and bottoms when we do the mirroring. Does that make sense? What about left and right? Does left go to left or does left go to right in this? Say that again? And left goes to right. So Joseph suggested that right goes to left and left goes to right. Do people buy that? I've got a couple of shaking heads. Does somebody who's shaking their head want to suggest an alternative? And why? More to the point? Anybody? I saw several people shake their head in this room. I'm gonna pick on somebody. Sophie, why did you shake your head? Yeah, right. So if we look at our initial thing, the tree is on the left side in both the top and the bottom. And the person, you know, let's say there'd been another person way over here, we want them to be over on the right. So if we did the idea of swapping lefts and rights, the tree would move over to the right-hand side and the person would move over to the left-hand side. And that's not what we're shooting for. So we actually do want the left to stay left and the right to stay right. So we're not going to actually change the mapping of left and right, which will be the x coordinates, but we are going to change the mapping of the y coordinates. Okay. So let me write that down. We'll turn this into code here in a little bit. So left maps to left, and right consistent maps to right. So x in top stays the same in the bottom. So if we have some pixel xy, it's going to map to a new pixel and that new pixel's x coordinate is going to be the same. We're not going to change that. Does that make sense? Questions about that? Joseph, good with that?
Yeah.
Cool. Now, as we've discussed though, the top and the bottom are different. So top maps to bottom. So y in top changes. So we're going to have to figure out what that looks like. That's the important piece. Okay, so how do we do that? Well, go ahead, Nick.
I was thinking if you wanted to use like math, theoretically, the component of y at the top image and the component of y at the bottom image are going to add up to the height of the two images combined.
Oh, nice. That's a nice way to think about it. Okay, so let's think about what Nick just said, and I'll repeat it for those of you at home that didn't hear it clearly. I'm actually going to make a new screen here because I think this will be easier if we have a clean piece of stuff to work with. So, ah, so what Nick said is that if we have a pixel here and a pixel here, and let's do a few different pixels. Let's do a red one. Let's say right up at the top, and has its mirror image down here at the bottom. And let's do a blue one that's down here at the bottom, whose mirror is right there. So Nick's idea, which is actually really clever, is that there's a thing called an invariant here, so a thing that's true about every pixel. And that is that the x, no, sorry, y, y top plus y bottom is always the same. And if we look at the y coordinate for this red guy is 0, right? And so, but the y coordinate at the bottom is 2h minus 1, right? Because our thing is 2h, and we start counting at 0, so we've got 2h minus 1. So the sum of these things is always going to be 2 times h minus 1. And we can see that that's true because as we come down 1 on the top, we're going to come up 1 on the bottom. So coming down 1 adds, let's see, let me do purple. If we come down 1, we're going to come up 1. So we're going to add 1 to this and subtract 1 to that from that, and they'll still add up to the same thing. Okay. And so every pixel is going to have this nice property that if we add the y coordinates for the original position and the new position, those are going to add up to the same thing, which means that in this case, this tells us that y bottom, doing just a little bit of old school algebra, is 2 times h minus 1 minus y top. So if I know the y coordinate of the initial pixel in the source image in the top, I can compute the y coordinate of the target pixel in the bottom by taking 2h minus 1 minus y top. and that's going to get me in the right place. And, it's not critical that you totally are comfortable with the math that Nick suggested, although it's dead useful math, frankly. But if you can sort of work this out by just thinking that, if this is 0, I want this to be 2h minus 1. So that's this part here. And then as this gets bigger, I want this to get smaller. So I want to subtract y top as a way of pulling this up as this comes down. Okay. So hopefully it sort of makes some intuitive sense as well as having some nice math to back it up. Does that make sense? Questions about that? This is actually really critical, because if you don't understand this, then doing the other mirroring stuff is not going to work. Questions online? We good? Okay. Awesome. So we now have enough information that we can turn this into code, because this is really the crucial piece here, is knowing that y bottom is 2h minus 1 minus y top. If we get that to work, the rest of it will all be golden. Questions? Okay, let's do it. I'm going to move the drawing board out of the way, and I'm going to stop sharing that, and I'm going to start sharing Jess. First, that means I have to start Jess. Do. Questions while we're waiting for Jess to begin? All right, Jess has begun. Share screen. Jess. Okay, so def, horizontal mirror. And I'm saying horizontal mirror because we could also mirror, well, I guess this is a vertical mirror, isn't it? It's always befuddles me. I name these things wrong. So we're mirroring vertically. Yes? Go ahead, Jess. Yeah? Oh, yeah, sure. So an actual physical mirror leaves the top and the bottom the same and swaps left and right. Yeah, totally. Which is just a weird effect. And we could do a horizontal mirror where instead of taking the picture and sort of folding it down, like we're going to do, we could take the picture and fold it out horizontally and end up with 2 copies. And that's actually a totally cool thing to do as well. And the math there is pretty similar, but instead of the x is staying the same and the y's adding up to the height, twice the height, if you mirror the other way, the y's stay the same and the x's add up to twice the width. So it's more or less the same thing, but you're kind of swapping heights and width. So mirror the given picture vertically, stacking the original on top of a copy that is reflected vertically. Here, the reflection will map left to left and right to right. So the x coordinates will stay the same, but will map top to bottom and bottom to top. So the y coordinates will have to change using the formula y bottom equals y top 2 times height minus 1 minus y top. You know, that just captures the stuff we worked out over on the whiteboard. So questions? So the result is going to be a new picture. What tool do we have that makes a new picture? Like, how do we make an empty picture? I think it's make empty picture, isn't it? Yeah, but close. Make empty picture. And, oh, we need width and height. So make empty picture takes width and height. So I'm going to just say WH here, and then we'll say W is get width of the picture we were given, and H is get height of the picture we were given. You know. So that makes the new empty picture. You good with that? Nick looks not good with that. Oh, well, oh, yes, right. So what I made a mistake. What's the mistake I made? Yeah, height heavily needs to be doubled. That was just me being stupid. Good catch. So yeah, we needed to double the height so there's room for both copies. If we had not done that, we would get an error at some point pretty quickly saying, hey, you copied a pixel down into a place where pixels, we don't have room for pixels, and bad stuff would happen. Okay. Now we need to go through all the pixels in the original image. How are we going to do that? Get pixels for pixel in, actually we'll say, call it, yeah, no, we'll just say pixel. Pixel in, get pixels, picture. So now we have a pixel. How many times do we need to copy this pixel into our result image? How many copies of each pixel will there be in the final picture? I've got a 1 and I've got a 2. You want to vote for 2? Explain your vote for 2, Darren? Because it's mirrored. There's a copy of the pixel in the top part and a copy of the pixel in the bottom part. So for every pixel, I'm going to have to copy it into 2 places. Okay? So let's get x top is get x for pixel, and y top is get y for pixel, and color is get color for pixel. And so we can set color. Oh, I need to get the bottom pixel. So I need to get the, oh, the naming is going to get weird here. So I could say, yeah, I can say top pixel is get pixel in result x top, y top. And then I can set color, top pixel, color. Okay, so this point, I have copied the color from the top pixel, from pixel, sorry. I've copied the color from pixel into the top copy of the picture in the result. Okay? Does this make sense? And actually, I'm going to use a trick here that I recommend, which is, you know, as you're going through, don't try to do all of it. Do parts of it and see if they work. So I'm actually going to save this knowing that it's not done. to see if like I seem to be anywhere near the right place. Today's the 21st, PY, load. And I'm going to set media path. And back up. What? Ah. What's going on? Why do I not have my picture? Where'd my pictures go? That's weird. Because they were in desktop. 1201. Huh. Oh, I know. It's only showing me directories, and I don't have a subdirectory for images here. And so if I get make picture, actually I'm just going to pick a file. I don't even remember what's in this directory. Let's do, we'll do Park Avenue. And so we'll show the picture just to make sure we remember what the picture looks like. Share. So there's the picture that we're using. We'll go back to Jess. So let's say mirror is, what do I call my function? Vertical mirror picture. Show mirror and share that. And indeed, we got the desired looking thing. So we've got our original picture at the top, and we got a big blank white space at the bottom. So far we seem to be in good shape, okay? And so I definitely recommend, highly recommend, enthusiastically recommend doing these kinds of things in pieces when at all possible, because they're just more likely to work if you do them in parts than if you try to do them all at once. So now I have lost the ability to close that. There we go. Stop sharing. Go back to Jess. Yeah, the more you try to do before you get feedback from the computer, the more likely you are to have made a mistake and then have trouble finding it. And this is actually mirrored, ho, 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 pun sort of intended, by best practices in the field as well. If you're writing software for a customer, getting feedback from them as early and as often as possible is a good idea, because the longer you wait, the more likely you are to be just solving the wrong problem and not realize it. And that's bad. Like you're spending their money, but not doing what they want. And this is not a good way to make your customer happy. So definitely recommend checking in as often as possible. Okay, so now let us say we want to now copy the same pixel color, but into a different pixel. So we now need to get the bottom pixel. And as we discussed, the x coordinate doesn't change. Actually, let's be really explicit about this. Let's say x bottom is just equal to x top, right? We're saying absolutely explicitly here that the x coordinate doesn't change when you go from the bottom to the top, but that y bottom will change. It will be 2 times h minus 1 minus y top. Okay, So that's our equation. We're taking twice the height, and we're subtracting 1, and then we're subtracting y top. And then we can say we want x bottom, y bottom, and then we want to set the color bottom pixel to be colored. So we want the bottom pixel to have the same color that we had for the top pixel. That's a lot. So holler if you got questions. Are the people who are madly typing doing okay? So we try running it, see what happens. Save, load. Come on. No. Mirror equals, oh, so just up arrow. Waiting for just to do its thing. Dun, 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 dun. There we go. Show mirror. And share so you can see what cool picture we just made. Voila. That's pretty slick. It's a neat effect. And actually on this one, this sort of pattern in the road becomes particularly interesting. I don't think it does much in the original picture, but in the mirror, actually, it makes for a very interesting effect. And it's weird that this little bit of shadow here from the sign or whatever's going on there makes for an odd little bump when the sign mirrors. I hadn't actually noticed that really, but that's kind of funky. Questions? Are people that are playing along at home getting it to work? I feel like Sophie has a question. Are you loaded? You willing to share your screen? That'd be awesome. I will stop sharing. We'll have a look at Sophie's screen, see if we can figure out what's going on. Other questions? We're waiting for Sophie to get into the meeting and share. One thing I'll point out, and holler when you're ready, since I just re-grabbed the sharing. This takes a picture and returns a new picture, right? In some of our examples, we've taken a picture and just modified the picture in place. Here, we're taking a picture and making an entirely new picture. Sometimes it doesn't really matter. You can do it either way. But whenever the result picture needs to be a different size than the original picture, this is really the only way to do it. You're going to have to make a new picture and then put the desired information into it, because the picture you were given isn't the right size. So you can't just modify it in place. Okay, you ready to go? I will stop sharing. Go for it, Sophie. Oh, sorry. Thank you. Should have the ability now. Look at that. Okay. So, an attempt was made to call a function with a parameter of invalid type. Okay, so, okay. So Florida is not a thing, I think. So type show Florida. Oh, I lie. Florida is a totally reasonable thing. So get width, get height, make an empty picture, get pixels, get X and get Y on a pixel, get color on a pixel, get another pixel, set a color, X top, Y, X bottom, Y bottom, get a pixel, set a, oh, you're not returning result. There you go. Now try showing mirror of Florida or whatever you did, or mirror equals mirror of Florida. Yeah. There you go. Now show that. Oh, that didn't look good. Something is amiss.
Mirror, not Florida.
Oh, good catch. Well done, Nick. Takes a village. Hey, well done. Good job. So, yeah, so that return is really important. If you don't have a return statement, then you're not sending anything back. And that's where that none stuff came up, is you were setting mirror was they were trying to assign nothing to mirror when you did mirror equals mirror. And it was like, I don't know what to do there. And that's what that error was. Not a very helpful error message, but that's what that was doing. So good catch. Thank you. Other people, anybody else got a version you want to share or just a cool picture? Anybody like done this and gotten something nifty to happen that you want to show off? Cool to show off. Nice to share fun pictures. Let's do another picture. So we did park, and that was kind of nifty. Let's try doing tree, make picture, pick a file. I saw tree was there. Tree.jpg. And let's say mirror tree, vertical mirror tree. Show mirror tree, and share that. Screen share, and and come on, there you go. And so that's what we get with that, and that's pretty cool. Skies are often nice for this. You get nice effects if you have skies or clouds, things like that. That made kind of a cool thing. And some pictures make interesting mirrors vertically, like what we've been doing. Other pictures make more interesting mirrors horizontally. It sort of depends on the structure of the image. I think if there's interesting sort of vertical structure or things near the bottom of the picture, then a mirror like what we're doing is often nice. So Sophie's was nice because that path ran mostly up and down, so it just sort of continues down. If you've got a lot of structure that's more left to right or interesting stuff along the right-hand edge, then that's cool because it gets reflected when you make the mirror image. So yeah, there we go. We made a mirror. Yay, us. We're awesome. Questions? Anybody at home got questions? Oh, go for it. Yubo. Are you sharing? Or no, are you what? Okay. So while Yubo's getting on Zoom, does anybody at home have a question? We haven't heard from anybody at home. We good? Proof of life? Thumbs up? Something? Go Dong-Ting. Saving the world. Oh, look, all kinds of proofs of life. And there's Yubo. Awesome. Do. Share away, sir. Okay. So, oh, I see one mistake right away, and it's related to Sophie's mistake, but not the same. Anybody see it? Nick.
Return result has to not be part of the for loop.
Yes, return result needs to not be part of the for loop. If you put it in the for loop like Yubo had it, then that loop will do one pass and then immediately return. So it will copy one pixel into two places, immediately return, and you'll get a white picture with two pixels with color in them. Was that what you were getting? So let's try this and see if this works better. Because maybe that solved the problem. You probably have to rerun mirror. You probably have to mirror equals horizon mirror again. Okay, and then that one. Okay. Well, like it took a while. That's good. And then can you share the picture with us? Did it work? Oh, no, it didn't work. You just got the top half. So does anybody see why he would have only gotten the top half? Darren looks like Darren has a thought. No? Anybody? Anybody at home see why he might only have the top half?
He didn't set the color for the bottom.
Exactly. He didn't set the color for the bottom. So you've got one set color. Oops. Oh, that didn't do what I wanted at all because you don't get to see me select. But you've got one set color on line 10, but you didn't have another set color. And so you need that other set color. Now, set color is not an equals. Yep. There we go. That's better. And so what picked there go? Good. Yep, you're right. No, set color takes a pixel and a color. You're giving it numbers, not a color. So if you look at line 10, set color takes a pixel and a color. So you've given it the pixel, now you want the color. So what color would you set that bottom pixel to? Yep, bingo. Same color as the other pixel. you can use the up arrow and hit that twice, and you should get the mirror equal horizontal mirror command. Actually, if you just do the up arrow, I think it would, or that'll work, whatever. That's weird. I wonder if you pasted something. Did you paste a space maybe at the beginning of that didn't need to be there? No, I don't think it's in the program. I think it's in the command thing. Yeah, I think you copied a space where you didn't want one. Yeah, that's better. Python being highly sensitive to spaces can be confusing sometimes. Is that better? Can you share that so we can all see? Here. Nice. Nice. Very cool. Thank you. And I was thinking that one would look kind of nifty. The sky starts to look very watery in that. So, other question? About our mirror. And so this was the line that was missing with the second set color, which you now have. And then that was the return line that was missing in the other situation. So, and notice it lines up with the for loop, not indented. It's a little harder to see since it's not all on the same screen. But questions? We got 7 minutes. So as I said, if you wanted to mirror the other way, well, the first thing is the size of the picture would have to be different. If you wanted to mirror horizontally, you'd want to double the width, but keep the height the same. And again, like getting a piece of paper out or a whiteboard or something and sketching can be really helpful in these situations. And then, where before we left the X's alone and we changed the Y's, if you wanted to mirror horizontally, you leave the Y's alone and change the X's, okay? And you could change both, right? And that would actually give you mirroring in both directions, which could be kind of cool as well, in a totally different sort of way. So we got 5 minutes. Somebody ask an awesome question. Yes. Yeah.
You were to mirror both left to right and top to bottom.
Right.
Would you need a canvas that wouldn't it kind of be mirrored like diagonally?
Yeah.
Canvas that had 2 empty squares.
So that would be, I mean, if you wanted it to kind of, if you think of it as being kind of in relation to the original image, then yes, that would be a lot like, so the original image, the mirror would end up sort of down here in relation, and then you would end up with 2 empty squares. I mean, but you could also just mirror it that way and have that be a standalone image, right? If you wanted it to, or you could put them together and it would look weird, right? I mean, it's all of these are choices. One of the nice things about working with this stuff on a computer is that you have all those choices. You could do, I'm going to mirror it in both directions and I'll put it here and maybe fill the corners with black or gray or green or whatever. Or I'll put it here or I'll put it here, or I'll just have the mirrored copy and not have the original, right? All of those are possible, and it's computers, so go crazy, right? I mean, there's no reason not to explore and see what fun things you can make happen. And one advantage of it being digital versus like physical analog paper stuff is it's very easy to experiment. If you were doing like mirroring like this with film and printing paper, you could do that. You could take a negative and print it mirror image on paper with the right tools. But to see what it would look like, you would have to go in the darkroom, print the paper, develop it, and then finally get to see it, right? And then that takes time, and that takes paper and chemicals and all this stuff. And then if you don't like it, you're like, now I got to go through the whole process again. But with computers, you can be like, try that. Ooh, that's kind of cool, but I think this might be better. Try that. Oh, that was a terrible idea. Try this other thing, right? Digital materials like this make it so much easier to experiment than analog in a lot of ways. And the same will be true for sound later on. When I was working at a college radio station a long time ago, we actually did editing on reel-to-reel tape. So we had these great big reels of tape, and you would edit by literally taking a razor blade and cutting sections of the tape out and taping the sections of magnetic tape together with little clear plastic splicing tape. And so, if you got it wrong, if you cut out the wrong piece, well, you cut out the wrong piece. I mean, it's gone. It was much more complicated than doing the kind of editing that we'll do in Jest with sound. And images, same thing. We can do a lot of things with images much more easily and much more quickly. It's a lot simpler to experiment with computers. And if you've ever used an image editing tool like that's on your phone or something fancy like Photoshop, it's so trivial to do all kinds of things. You can just be like, oh, what if I do this? And if I blow out the color or use this Instagram filter or whatever, that kind of stuff becomes super easy. So really nice. Okay, so we've got like 1 minute left. Anybody want to ask the last question? I will try to get the take-home part of the exam posted by tomorrow night. And we can discuss the exam on Wednesday, and then the in-class part will be Friday, yada, yada, yada. Okay. It has been a pleasure. I will see everybody later. Ciao.